Hello folks, today we're going to be working on and showing you this design. This is a small turbine. It's about 60 millimeters in diameter, and this is the entrance for the high pressure, and this side is for the low pressure. Here's the turbine, and this is Solidworks parts. And from here, when you get all these 4 parts done, then you jump and do the assembling. So you move down here, and this is pretty much in assembling. As you can see, that I already did some part of this were done already on flow simulation, because you can see right now that I have a plug here for the shaft, and also a plug for the flow in, and also for the flow out. So but this is in assembling. And how you know that? Because you can rotate the rotor, you can see it right here, and everything from here. Then you go to do flow simulation and you get the job done. So the idea of this video is how you do that. And also right at the end, I'm gonna be showing you also some of the many flow simulation. You can see there are some of the many iteration, because you have to iterate a lot just to get this right, in terms of, you know, getting that mesh size that properly start to get you real and good numbers. And basically, like for example, if I jump right at the end, you can see here that I pretty much, this one was, I finished it prior to 1 second, completing the 1 second study, because pretty much it was not changing much, particularly the torque here, which is the most important part of it, and the drop, and the pressure drop, which is less than 1 psi. But anyway, because the inlet pressure was 40 and now I got 1 psi, so 39.4. So as I said, less than 1 psi. And the torque, this is with the turbine at 0 rpm. Then you can start to mess with the rpm of the turbine, and you will see that these numbers start to drop. But that's the idea. Alright, so again, this was some flow simulation. You can see some of the diagram like this one here, showing you where it's going to be the highest pressure. Like for example, when the flow rate strike the rotor right here, you develop a little bit higher pressure than from the inlet. And so this is the outlet as shown here on the colored bar. So that will do. So let's go back now to Solidworks and let's get this going. Alright, so we are ready here to construct our turbine. So let's see, let's start here with a new part, and we want to work on millimeters. Let me do some improvement here. Plain white, that will do. So let's start working first with the front plane, and let's create the base of our turbine rotor, and that should be about 60 millimeters. And now on that direction, on the Z direction, let's do the extrusion. So we go features, extrude, and we're gonna do that extrusion. It's gonna be 5 millimeters. That will do. We accept that, and we have the base for our turbine. So, and the next will be on this face, let's do a sketch again, and that will be for the center that's going to be holding the blades. Let's do that about 20 millimeters. Let's see. Now let's do a construction line from here to the center of the outer circle, and let's use that as a guideline. So we're gonna do is a solid line from here to here. Now that line should be straight. There we go. And then construct another one. You can use meter if you want to, like for example testing meter entity here. You can, I mean, just for testing entity to meter and meter about, that would be about this line, and the entity that you will mirror is this one. So we can accept that. And now you can also construct a line if you want to. Now the distance here between this line and this line, that distance you want to be kind of thick, so I would say good 4 millimeters. That will do. Now everything is tangent or at least touching here. That's important. What I'm gonna do now is, for example, this center line, I can delete it for the time being. You can see that everything turned different, but still it's kind of touching here, although I kind of lost the connection. Let's see something here very quickly. Nope, that's okay. All right, so anyway, this was mirrored against this one, so this one is touching here and touching here. That should be as well, but if not, I can always double check just to ensure that both lines are on that case kind of touching each other. Let's see, there we go. How about the one at the top? Want to be sure that that one and this, good. Now that will do, because I want to avoid problems. So the next part here is to construct how many of these I really want after that. And so this is what we're gonna do here. We're gonna do a linear sketch pattern. It's gonna be circular, and what we gonna, the entity to pattern, and that will be obviously this line and this line. And how many? 8. That's what we said. And it looks good at this point, so we're gonna accept that. And the next part, as you can see, they are not well defined because they're in blue, although I don't care at that point, because basically I want them, I would not be moving them at all. So what I want is them to go here, features, and we want to extrude them. And here's the story. What we gonna extrude? Obviously that, the center as well, this, obviously this one, and finally that one. See, it's gonna merge against that base, and the distance is about an inch, 25.4. So that will be good enough for that. So we accept that, and it looks good. I don't see it looks good, so we're gonna accept that at this point. And basically there's our rotor. It's perfect and strong. All right, it's gonna be 3D printed in PLA, so that's why you want that to be strong. Now the next part is, depending of where you're gonna be doing flow simulation or not, you need this. For 3D printing you don't need it, but since we're gonna be doing a lot of flow simulation, so we want to what is called the rotating region. And for that, basically pick this face and do here sketch, in where that sketch, that circle there will be about slightly larger than this one. 61 will do, and we would not get into the other solid, which is the casing of the turbine. 61 is perfect. I learned doing a couple of things here by mistake. If you make these the same size of the turbine, you make the rotating region the same size of the turbine, Solidworks or the part of flow simulation, we have a hard time to separate those two entities, and the result will be awful. I mean, it would not make any sense, and you will have a very weird result. So you want to make it slightly larger, so the 61 versus the 60 is okay. Now, as you can see, that surface is touching this surface. That's bad as well, but we're gonna fix that in a second. At that point, it's perfect. That's where we are. So what we're gonna do after that is complete the extrusion. So here we go. Now that extrusion need to be two-sided. So first of all, the direction is wrong. We're going to change the direction. Now where, here we go. This is what we're going to do. There's two directions here. We're going to make this a slightly bit larger than that one, so that 25.4, let's see how the math will look like in a second. On direction 2, definitely we need a direction 2, and that will be about 1 millimeter. It's more than enough from that surface, from the surface of the blades. You see, that 1 millimeter is perfect there. What we need now is to ensure that we cover this, so that 25.4 we're gonna add, for example, we're gonna add the 5 millimeters, which is this part here, the base. Let's see, blind, there we go, it's right there. Now it's up to here, but we need a little bit more. How about if we add another 1 millimeter? So we're gonna add plus another 1 millimeter, and so we end up with about, could be, that sounds super to me. And let's see, we cannot, in other words, the blade or the turbine cannot be seen when I finish here. So let's say that we are okay. Now the merge here gotta be removed. There's not gonna be any merge there, because this is a rotating region which encapsulate the rotor. So looks to me that we are okay there, so we accept that. As you can see, it's just a solid, you don't see anything else. Now there should be two bodies at this point. One body, which we're going to change the name right now, rename, that's going to be called the rotor. Oops, let me put this right, the rotor. And the next body, this one here, we should change the name as well. We're going to rename that as the rotating region, or rotating body, as you want it. Oops, I think that I better run. That will do. Now if I hide this one, there we go, you can see the rotating region in blue versus the in this case the rotor, which is solid as shown here, and that will do. So now we have two bodies, the rotor and the rotating region. The next part is to start to construct what I call the casing. For the casing, we're gonna move this a little bit. Let's see, we're gonna use this as our starting point, but it would be easier if I use that and use a plane, so that plane will help me to get the casing easier. So, and let's do that. Would be what would be a good distance to get that done? That would be about 2 millimeters. Because that's the casing. So the casing is totally, it's not going to be touching the in this case, either it will not touch the rotating region, but it also will not touch the, in this case, the rotor. All right, so that will do. That's where I want that. So let's accept that it's fully defined. We don't have any problem there. Now on that plane, and we want to do our sketch there. And let's see where it is looking. All right, let me flip it around. Good. So we're gonna do our sketch here, and that will be, let's work here. First of all, a circle there. Now that circle should be big enough to be far away from the rotor. So I want a distance between those two guys, between the rotor edge or rotor diameter versus that guy should be, I believe, about 2 millimeters. Good. So we got 2 millimeter defined between those two concentric circles between them. Now, that's the inner of the casing, so we need a second one, which should be a little bit larger than that, but then you want that outer circle to be at a distance that will allow the casing to be strong. That would be about 5 millimeters. There we go. So this, between this circle and this circle, is where you're gonna construct finally your casing, starting from a distance which is about 2 millimeters from here to here, and you're gonna give probably 2 millimeters from as well down here. All right, so that will do. Now with that said, what we have to do now is to complete the extrusion. So let's do that. And wrong direction. Let's pick the direction here. It should be that way. And now we need a little bit more, because remember that final distance is, you have 2 here, plus then you have 25.4 here, and then you have 5 here, but you need 2. So let's work the math here. So the math is 2 millimeters from here to here, plus 25.4 plus 5, which is the base here, plus 2, another 2 here, plus 2. And that will do, you see? So you don't see, like, the rotor is kind of a, you have a clearance of about 2 millimeters, which is almost nothing between the base of the rotor and this part here of the casing for the turbine. So with that said, let's see if I have to do anything else. We need to, in fact, this system kind of pick for us the selected contour. Let's see, I haven't picked it yet, but I will now, just to ensure that region is the one that we're gonna be working on and look good. So I have merge here, but it's not gonna merge to anything. We'll see. Perfect. So we got that. So that is just the casing. It didn't merge to anything because it's not touching anything, so, but we're gonna change the name quickly, and we're gonna call that casing. So we have the casing now, and so we have 3 bodies at this point. So the next part is to work on the bottom of this surface here, and this surface is very important because we are going to accommodate that surface, need to accommodate eventually a ball bearing, and the ball bearing is the common 22 millimeters outer diameters with a shaft of 8 millimeters. So, and the thickness of that ball bearing is about 7 millimeters. So this needs to be thick enough to accommodate that ball bearing. What we're gonna do there is we're gonna use this surface, and we're gonna create a sketch there, and basically we're gonna do a circle here. Actually, I don't have to do that circle. I can use, for example, use this here, and that one, and do a convert entity, and from there I can do our sketch, and instead of be 34, and it obviously had to be merged, we're going to be about 10 millimeters. So the idea is that's thick enough to accommodate that ball bearing there, and it looks good at this point, so we're going to accept that. Merge, yes. So it's going to be still 3 bodies, but now our turbine has this bottom part here, which is part of the casing, and we can take the casing off, so you see the rotors and all other parts. But at this point we need the casing, so I'm going to put it back. There we go. So 3 bodies at this point: the rotor, including the blades, 8 blades, the rotating region, which is only for flow simulation, and the casing. So the next step is to construct the inlet and outlet for this turbine, and for that, that plane, let's get that plane, let's hide the plane, and now let's check where I'm gonna make this. Let's see, let's take a 3D of this kind of a isometric. So I'm gonna make the inlet and outlet in this on the x minus x direction. So with that said, that would be right plane, see, right plane, and so water will in the inlet water will be through here, and the outlet will be down here. So I need to create a plane on this side. For that, let's go reference plane, and let's see where this is looking. Flip direction, and let's increase that to about what would be a good distance. Let's leave it at 62. Remember that you have to design that distance so you're able to, to work on the connection for water hoses getting in and out. So I mean, this, you need to work on that as required, but at this point I only want to create some input and some output for this system. So I got the plane and it's fully defined, so we accept that. Now on this plane, and this is the story here, on this plane I want to construct the inlet. So the inlet basically will kind of the inlet water flow here will bypass pretty much, will have a clearance from here, but it's gonna hit this one. So that will be the idea. The idea is that between this line and this line is where you want to have that entrance of the water. With that said, we're going to work on this plane, and let's work on that plane. So we're going to create a sketch on that plane. Now ensure that the plane is looking into the right direction, which is not at this point. Change it again, change it again, and now yes, now it's working on the right plane. So you see, that's what I was saying. Now from that plane we need to do a couple of things. The first thing that I need to do is the casing there is creating me a problem. I don't see the rotor, so let's hide the casing in the time being, and let's put this back. And here's the story. Between this line, between this line and this line, which are belong to the rotor, is where we're going to construct our water flow entrance. So what we're going to do, convert entities, and we're going to pick this line and this line, and we're going to convert those entities, and those entities now belong to that plane here. Now let's do this a couple of times so this looks better. Let's do it one more. There we go. So now they're aligned. Now let's do a center line here, right at the center here, and the center here. That's a construction line. And from the center of these, we want to do the inner circle for the water flow. So let's do this and right there. Now don't hit the borders, because it tried to tie them up to some specific side as related to any of these 2 points. So I want to leave it the way it is. And so let's see, typically I'm gonna leave that size to about 8 millimeters, slightly larger than the distance between these two lines from the turbine. Now we're gonna enclose that entrance with another circle, which you see, be careful with that, so because it's kind of locked and you don't want to lock too quickly the distance here. That radius could be let's see, that radius could be, that's huge. I think about 12.5 will be more than enough. That will give us a thickness between 8 and 12, about 4.5 millimeters, which is strong enough. That will do, and it looks like we got this pretty much done. Let's accept that for the time being, and let's put back the casing. So now I see it. So that's the story. This is how that looks like. Excellent. So what we're gonna do now is complete the extrusion, and for that we're gonna pick selected contour. It's gonna be that one, that one, that one. Now up to where? Well, gotta touch this guy, so that means that instead of blind, up to surface. Which surface? We pick this one, obviously that one, that's right there. So we got the surface right. Oops, let me get this out of the way. So that looks good. We're gonna accept that, and should be merged with whom? It should merge with, obviously in this case, with the casing. So let's see, accept that. We still have 3 bodies, which is the casing. You see how it picked everything? Excellent. So now the only thing that we need is to work on this plane. Let's do a sketch here, and this, what we're gonna do with that is convert entity, and we're gonna do features, and we're gonna do a extrude cut. But here's the story. Before that extrude cut, we want to be careful, because if I do a extrude cut, maybe I'm gonna take out the turbine, because I want to do that kind of blind. Let's see, let's take a look just to see what happened. It's gonna be blind, and let's make it long enough that it kind of go all the way. So you see, it might damage the rotor because it's not, you're still showing the rotor. So let's accept that, just to let you know what's gonna happen. You see, that's what's gonna happen, and you don't want that. Definitely you don't want that. So let's go back here 1 second, and before cutting anything, let's go to the rotor and hide the rotor. Now the rotor is not there any longer, so we're gonna go back, and now features, extrude cut. And now, since those measurements were there, we are ready to go, and we say yes. And now there's the entrance, and now let's put back the turbine, in this case the rotor, and the rotor is perfect. You see? So that's the water flow. It's gonna hit very strong this blade here at that, at that opportunity. So that looks super. So we got the entrance done. For the exit, I think that we can certainly do a couple things here. For the exit, I can do meter. If I do meter, I can copy this back here using that plane, top plane. If I use stop plane, I definitely can do that. But let me redo that. Again, and let's see that exit might be like from here down here. I don't know. I need some of this line as a reference line, so we're gonna take the casing out for a second, and we're gonna work again on this plane. What's that plane? Plane 2. We're gonna work on that plane again. We're gonna rotate that again. There we go. Now what would that be? We want that to be kind of a large exit. So for a large exit, that I think we need to work out some of the numbers. Let's see how that will looks like at this point. The entrance is A. Let's get from reference. Let's see here as a reference on the angle that we are talking about. Let's get this line as a reference, and maybe this one as well. So let me do this. Convert entities as a reference. Definitely we're gonna pick that one. That one and that one. And you know what? Pick those three, but I definitely would like to get the casing back as well. And now that I have those three lines, I would like to pick the this bottom line here as well. So we're gonna do that just to have an idea of where the size of that outlet should be. So we're gonna convert entity, and we like to convert that one as a reference as well. And now, as you can see, I have all those lines there to have an idea. This is a general idea of what should I gonna do with that exit. So now let's work that. So the detail here will be, now let's write a line here, a construction line right at the middle of everything here. And now, with that said, let's work the detail of this circle right there. Now how big that circle should be. If you made it that big, it's gonna be a problem, obviously, so you gotta make it not that big. But let's see. Let's see. Let's work out the detail here, and the detail here is what would be a good size for the inner circle. Let's say 16, and here's the story. That's 16. So it's A in the entrance, 16 at the exit. That's twice. That looks good. Now we need to do now the cover of that exit. For that, let's go back here and let's make one. And here's the story. You see, right now it's tangent to the bottom line, and that's good, but it's huge compared with this part here. So that's going to be troublesome and doing so. So we'll see. Let's leave it there for a second, and let's see. Let's grab here for a second. Let's see where we are now. It don't need to be that big either, so I would say, see, 16, the inner was 16. I can 16 plus 4 is more than enough. 16 plus 4, we can accept that, and that's about 20. So it's a difference of 4, which is the same of here. So that looks good. I don't see a big deal here between those two, and we're gonna accept that. All right, and now the final thing is to do the same that we did on the top, which is do an extrusion. And for that extrusion, pick this, oops, pick delete that one, that one, that one, that one, and now up to surface, and the surface will be that guy, and that looks good. So we're gonna accept that. It's merged to the casing, which is the important part. All right, so we accept. We got that. Now the only thing that we need to do is to create the outlet hole here, and for that, again, get the rotor out, and now this face, this plane, we can hide that, and we can construct here, and again convert entities. Everything was converted there, and now the only thing that we need to do is do the stroke cut and pick the surface that we're gonna cut, which is that one, and here it can be blind, and that's good enough. Remember that one in the top. So we accept that, and now we can put back my friend, the rotor, and everything should look good. And that's the story. So we got the entrance and the exit for the water, larger, so that water can flow easily out without creating any back pressure. You can make it larger, maybe next time, but so far it looks good there. All right, so now let's work. After that, let's work on the lead for this turbine. So with that said, let's work on particularly on this face. We're going to work on that face, and for that we're going to do a sketch there, and we're going to convert entities again. What would that be? This, definitely that one. So those two are part of our lead for this, but we want to create, let's create a circle, because that lead will be bolted to sorry for this, that will be bolted. So we're gonna bolt that guy here, and that should be about about 20. Let's do this about 20. Now 20, and we're gonna create now let's see, that should be about, that's for the bolts, the passing through bolts. It's gonna be about 5. and we're gonna leave a reasonable distance between this center. Let's see. There we go. Between the center here and that, I have to leave a reasonable distance. Let's see if I got that right. I think it's picking the wrong direction here. Let me get this out and let me trim some stuff that is kind of creating kind of confusion here. There we go, and that will do. So, and so let's see. Let me see how this moves. Good. Now let's create a construction line just so I get this right. There we go. And now what I would like is this guy and this line be touching each other, and now what we want is a distance between this guy and that guy. That distance could be about a good 7 millimeters, so it's not touching this part here. I don't want to mess with the casing. It should be out the casing, so but it's strong enough because we need, you know, this is going to be PLA and have to have 4 millimeters. Is always good to have a distance, and you know, around 4 millimeters between this here and here. 7 is because it's from the center. All right, it looks good now. What we need to do at this point is to replicate that around the perimeter for the lead, and that should be, so we're gonna do is circular path here, and what we gonna entity to pattern will be that one and that one. So we got 4. I cannot add more because it will interfere with the entrance or the exit. So 4 is perfect. That will do. That looks good. So we got that, we accept that, and now we're gonna do an extrusion, and that extrusion gotta go up this way. So feature extrude. What we gonna extrude? We're gonna extrude selected bodies. We're gonna extrude that one as well. The distance is huge. Let's say 5 millimeters, just so they start to look better. But we're gonna extrude as well this. Be careful what you choose, because we want to extrude that, because that's gonna be where the ball is gonna hold the lead. Oops, somehow that one. Yeah, that's super. Now we got everybody on board. So now the part that you need to be careful here, you don't want to merge that, because that's a separate entity. It's going to be printed separately from everybody else. So, and that looks good. So we accept that. And now we have another body, which is this guy here. Let's change the name so we don't get confused here. Rename, and that guy name is Turbine or casing, turbine lead, or casing. Let's write casing lead. I would oops, this casing lead. So we got our last body is that one. I think we are pretty much done, except that this is holding to where here, right? We are missing how this is gonna hold this part here. That's simple. What we're gonna do is work on this base. So there we go. Now we're gonna convert. We can convert everything here, all the entities. Let's see, convert entities. Let's see what we need. Convert entities. And actually convert entities. Let's go here. I think that they're all them. No, only the ring was converted. I'm gonna pick it again. That one, that, this one as well. This, that, and that. All right, so we're gonna accept all that and check whether they are there or not. Yep, they're right there. That's very straightforward. Now what we need to do, we're gonna add, be careful here. You want the casing lead to hide that away, and then now you are ready to do the extrusion of this part here. So we're gonna do that is feature extrude, and it's looking the wrong direction that way, and we're gonna extrude is obviously this part, that, and up to where? Up to this surface, So with that said, we're gonna change, instead of line, up to surface. That surface, you're right, you have it right there, and we are pretty much done. Merge result with the casing here, so we accept that. And now you see, basically what's going to happen is we put back the casing lid and we are done. That's the story. We're going to bolt it, pass through bolts with a nut here and a washer and so forth, kind of a pressure washer, so that this get always tight. And that's basically how this turbine has been done. And only 4 parts. The rotating region is again only used here for what? For if you want to do flow simulation. From here, the only thing left is to do perhaps an assembling, and perhaps from the assembling just do then the flow simulation, although you can do flow simulation right from here. So I don't know, it's up to you from where you do it. But here we pretty much complete this video about how to build this turbine. It's a small turbine, it's only for testing purposes, academic purposes, but then you can here, you want to see the inside of this, do change transparency, hit it here, you don't see anything because you are now at the second phase of the first of the lead. So hit back here, do right click and do again change transparency, hit here, and now you see the inside of that turbine of what you have. You can do more fancy rotor or impeller here or so forth with different type of blade, kind of a curved, but this is the first trial. And the idea of this is to 3D print these parts. Basically the casing will not change, and only you change then the type of blade for your testing. More blade, less blade, curved, kind of a weird type of design, maybe a Pelton type of design at the end here instead of this plate type of palette type of blade. You can go through many iterations of what the thing that you will do for see how much energy you can extract. There's a couple things here before and there that you have to be to finish this. Obviously I haven't finished, or I need to do the location, how we're gonna locate the shaft, right? There's a shaft here that we need to be careful. And with that said, let's get this rotor. Let's hide the rotor, and now on this surface is where we're gonna locate in this case the ball bearing. So what I'm gonna do on that center, the ball bearing diameter is about 22 millimeters. Here you need to do kind of a small print, most 3D print, a tiny, just to be sure that it fit because you don't want to sand too much. So I would say maybe 22.1, 22.2. You know, there's a little gap, but that the ball bearing fit kind of tight, right? You don't want the ball bearing kind of dancing on this. So you want to be a very good, good fit. Just the time being, you can add like a 1%, 2%, 5% maximum and see how well it fit. But in the meantime, I'm gonna set it to 22 because that's what the specs say about the ball bearing. So it's 22. Now we're gonna cut on that wall. We're gonna cut, and the cut will be a good 7.5 millimeters. So blind. And we're gonna cut. Let's see what's the direction here. Yeah, looking good. It's gonna go 7.5 because the ball bearing is about 7, the thickness. So I'm gonna come up 7.5. We're gonna accept that, and there we go. That's for getting the ball bearing right there. Now the shaft through the ball bearing, that's another cut that you have to do right here. So with that said, we go here again, and we do that there, see, and we said that that's gonna be, again, remember the shaft is 8 millimeters, so there's always some percentage of it that you gotta be sure that it's not too tight but it's not too loose either. So I would say 8 at this point, and we're gonna cut that as well. If you're gonna do flow simulation, that need to be plugged at a later time. I mean, that's during flow simulation. There's a technique that you can plug this, and this. I don't care about this one because there's no flow through them. So, but there's flow through here, inside here. So you want to be sure that this one is plugged, that this one is plugged, and this one is plugged. And that's part of flow simulation, which is another chapter. At this point, I'm gonna cut that off. So features, extrude, and you're gonna cut that up to, you can leave it the way it is, 7.5, but you can change it to up to surface, and the surface will be that surface, and you're done. So that's basically where you're gonna pass your in this case your shaft for your rotor. So let's put this back in perspective. Let's see where we are now. Let's put back the rotor. Yep. All right, so we pretty much done here. So we create the shaft, to accommodate the shaft, and to accommodate now let's get the rotor out to accommodate the ball bearing. So the only thing missing here is to create, at least on the rotor side, on the inlet part, where the shaft will connect there. So, but again, that depends on what you're gonna do. Definitely, I'm thinking it's gonna be metal, the shaft connection. So it will come out through this side. So here you will have a pulley or something to measure torque and things like that. Kind of a horse brake pony or something like that, and anything that can measure torque, you can use that, or you just put together like a motor or something that generates some electricity, and you can measure watts. That would be good as well. So but at this point, this is done. What I would like to entertain at this end is to go from here to what we're gonna do. We're gonna do assembling. So from here to assembling, let's do that. And let's look. I have done several revision on this turbine. Let's go document here, and let's look for well, would that be say here? It's gonna be a rep 6 of turbine. I have done many design, but I decided to pick on this one for this video. So it's gonna be turbine rep 6. Oops, like long diamond. Turbine rep 6. We're gonna save that. All right, so now we're gonna do assembling from here, and to do assembling I have to do a couple of things, like for example every element here on the solid body that you want them on assembling, you have to make this part independent, meaning that I have to go here, for example, insert into new part, accept that, and just say yes, and that's where my rotor will come out. See, this is part of that turbine rep 6, so having this as part of the title is good because I know what revision it is, rotor, so we save it. So that's one part. Now we can close this and go back here, and now rotating region, I need that as well. So because we're gonna do flow simulation, that's why I need that. So insert into new part, and we say yes here, and we say yes, and rotating region for rep 6, we save it as well, and we close here. And now the casing lead, we go back here and say insert into new part, accept that, and yes, yes, and we can close here and go to the casing finally, and insert into new part. We accept that, and yes. So we save everything, and now we can close this. I don't need it anymore. And what we're gonna do from here is go to make an assembly, say okay. So I picked the fourth thing that I need, and now casing is what I need. That's the casing. We got the casing. Now what I need from here is to keep adding, in fact, say component, let's look into that, browse. The rotor. So I got the rotor, and from that rotor we're gonna move that rotor somewhere here, and what we're gonna do, this is fixed, so it cannot be moved, and that's good. It's good the way it is right now. So what I'm gonna do is this part here and this part here, the inner ring, will be concentric. And now the distance, if you remember when we create this, the distance from there to this bottom face was about 2 millimeters. So we want to keep that distance 2 millimeters. We're gonna accept that, and that's super. That's what it should be. And now we have kind of a properly set turbine, so you can rotate, do anything that you want. The next part is just to add the rotating body. You have to put that rotating body there, otherwise if you're gonna do flow simulation, there's gonna be a problem. So let's get insert component. Let's get, in this case, the rotating region, and we're gonna put that somewhere here. And this is a story. If you remember, that rotating region, well, it's kind of concentric again with that part there, but this is a story. This surface, or this surface and this surface, there's a distance between them which is about 1 millimeter. We're gonna accept that. And now, as you can see, at least from this side, you can't see the rotor anymore. So let's get the casing. In this case, let's hide the casing, and just to be sure that yes, you can see that the rotor is there, but you don't see it. Now, rotating region, hide component, and I got back my rotor the way it should be. So let's put back the casing. There we go. And I can go back to business of my turbine without a big deal. Now we just need to put the lead, and we are pretty much done. Insert component, and in this case we're going to browse again, and that is the casing lead. We open, we put that somewhere here, and basically we just need to match. For example, we're gonna match this guy with this guy. You can match with anywhere because there is the same with this guy, using control as always, and that would be concentric. So obviously you can move it because you're only matching. It's like you put a bolt here through here, and this will move. Now to fix it in space, just that guy and this guy, concentric as well. Now it's fixed in space. It can move back and forth, but that's it. See, now the only thing missing is that definitely you want that guy and this surface. You hit control and this surface touching, and you're done. So now you got your full build in assembling your turbine. Obviously every part was created originally on Solidworks parts, so I know that it's gonna merge perfectly. I mean, the whole thing's gonna get nice, so there's no issue about how this will fit, because it was created originally from the sketches in Solidworks parts. So now we're done on this part here. You can add bolts if you want to through master, through this Mac Master catalog, but at this point the thing that I'm interested is in flow simulation. So we are done here, and let's save everything and let's rebuild that everything looks good. So we are rebuilding, and let's save all, and this is going to be called within Turbine. This is Turbine Rep 6 assembly. A little bit. That's Rep 6. We save, and we're done. Now, what is missing here is where we want to go from here. Well, basically just do flow simulation to see how much energy, or in this case power, can be extracted from this tiny turbine under some flow condition that we're going to be specifying. Like for example, the pressure here is water is coming from your aqueduct system, so that probably will be about 40 psi in, and a flow rate between around, I don't know, between 1 to 5 GPM getting in and out. So under those conditions, then you're going to see how much energy can you extract from this turbine. So let's go flow simulation.